All right, guys. So the next thing we're looking at is example 5. Now, example 5 says, given that y is equal to x squared plus 2x minus 3, we're asked to copy and complete the table below. All right. Now, let's look at the table below. So the table below, guys, is actually called a table of values. This table here is called a table of values. Now, your table of values contains corresponding values of x and y. So each pair of values of x and y is actually forms a coordinate. Now, most of the values, two of the values of y are missing. The value of y when x is equal to minus 2, and the value of y when x is equal to 2, those two values are missing. Now, we are going to find them using calculation, but I'm going to guess that this value here is going to come out to be 5, and that this value here is going to come out to be minus 3. All right. So what you should observe is that the values of x to the right, the values of y to the right and to the left of x of minus 4 are the same. Do you notice that? To the right of minus 4, I have minus 3, 0, 5, 12. To the left, I'm going to have minus 3, 0, 5, 12. So because they are I'm expecting them to be the same. I'm expecting the value of y, the missing value of y on the right to be 5, and the missing value of y on the left to be minus 3. Guys, I'm pausing for a second. All right, guys. So let us see how we're going to use calculation to get the missing values of y. To do that, you're going to need the equation. Y is equal to x squared plus 2x minus 3. Now, the value of y when x is equal to minus 2 is missing. So I'm going to say when x is equal to minus 2, y would be equal to, so wherever I see x, I'm going to take out x and put minus 2. So this is minus 2 square plus 2 times minus 2 minus 3. So I'm expecting my calculation to give me y is equal to minus 3. Let's calculate. Minus 2 square means minus 2 times minus 2, and a negative times a negative is a positive. 2 times 2 is 4. This positive times this negative is a negative. 2 times 2 is 4 minus 3. 4 minus 4 is 0, and 0 minus 3 is minus 3. All right. So it looks like I was correct. The value of y here is minus 3. Let us look if the one on the right is going to come out to be 5. So same equation, y is equal to x squared plus 2x minus 3. I'm going to say when x is equal to 2, because the value of y when x is equal to 2 is missing. So y would be equal to 2 squared plus 2 times 2 minus 3. 2 squared is 4, 2 2s is 4 minus 3. 4 plus 4 is 8, 8 minus 3 is 5. So the value of y when x is 2 is 5. All right. So by looking at the table, guys, what do you suspect is going to be the lowest value of y? Just by looking at the table. What do you suspect when you draw your graph is going to be the lowest value of y? Anybody? It's all right, don't answer. All right, we're gonna draw this graph. So we have done I, now we're at II. II says, using a scale of 2 centimeters to represent 1 unit on the x-axis and 1 centimeter to represent 1 unit on the y-axis, draw the graph of y is equal to x squared plus 2x minus 3 for x less than or equal to 3 and at the same time x is greater than or equal to minus 5. In other words, so by stating this, the examiner is telling you the domain values or the range of values of x over which your graph is going to be drawn. So your graph is going to be drawn from x is equal to minus 5 to x is equal to positive 3. Guys, if you're going to draw a graph, the first thing we're going to do is we're going to prepare our graph sheet. All right. So the first thing we need to do is we need to draw our vertical axis. All right. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, so 18 centimeters going across. All right, I just working some stuff out. I have 18 centimeters going across. I need 10 centimeters to the left. I need 6 centimeters to the right. So I need 16 centimeters altogether. So I have 2 centimeters to spare. So I can drop my graph within here. All right, I know what I just worked out in my head. Now, guys, the first thing we need to do is to decide where we are going to put our y-axis. That's the first thing we need to do. Here's what we know. The scale on the x-axis is 2 centimeters to 1 unit. Your graph is to the left, your graph is going to go to minus 5. To the right, your graph is going to go to positive 3. Guys, where do I, so therefore it is clear that I need more space to the left, because to the left, my graph is going to negative 5. To the right, my graph is going to positive 3. Guys, the scale is 2 centimeters to 1 unit. On the left, I have 5 units and I need 2 centimeters for every unit. If I need 2 centimeters for every unit, and on the left, I have 5 units, it means I need a total of 10 centimeters to the left. So what I'm going to do is I'm going to take 11. Calling the left margin 0. Calling the left margin 0. I'm going to count, this thing hates me. I'm going to count 11 centimeters. So watch me, everybody. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11. On the 11th one, I'm going to draw my vertical axis using my ruler. So on the 11th major grid line, I draw my vertical axis using my ruler. I'm going again. All right. So this is my vertical axis. I'll just line it up. All right, so that's my y-axis. All right, let's erase these lines. This is my y-axis. So I'll label my axis. All right, sometimes persons put arrows on both sides of the graph. So the next thing I need now is I need to determine where to put my x-axis. Now, the highest value of y is 12, and my lowest value of y is -4. Now, above the x-axis, y is positive, and below the x-axis, y is negative. So obviously, I'm going to need more space above the x-axis where y is positive. So I come back to my graph. All right, 12 at the top, 4 at the bottom, so it's sort of like 1 to 3. It's 1 to 3, so it's like the thing divided into 4 quarters. All right, so I think that maybe around here I can probably put my x-axis around here. So it's just an estimate. I didn't all right. So this is my x-axis. And as I said, some people put arrows on both sides of their x-axis. Stay with me. So the next thing we need to do is we need to label our axes. So where the two axes meet is the origin. The scale on the x-axis is 2 centimeters to 1 unit. Remember, your x-axis, you must be able to go to 3 to the right. So that's 1 centimeter, 2 centimeter, 1. It's 2 centimeters to 1 unit. So every 2 centimeters, the number goes up by 1. 1 centimeter, 2 centimeter, 2. 1 centimeter, 2 centimeter, 3. Over to the left, 1 centimeter, 2 centimeter, minus 1. 1 centimeter, 2 centimeter, minus 2. 1 centimeter, 2 centimeter, minus 3. 1 centimeter, 2 centimeter, minus 4. 1 centimeter, 2 centimeter, minus 5. Skillfully done. All right. Now the scale on the y-axis is 1 centimeter to 1 unit. It's a different scale. Now on the y-axis, every centimeter, the number goes up by 1. So this is 1. All right, my graph must at least be able to reach 12, 11, 12, so good. 13, 14, 15. I have plenty of space. Down by the bottom, it must go at least to 4. Still good. I have plenty of space. Let's start to plot our points. You guys can probably help me there. The first point is -5, 12. -5, 12. So this is the vertical line, x is equal to -5, and the horizontal line, y is equal to 12. The two lines meet here. So this is the point. That would be the point, -5, 12. All right, obviously we're not going to draw these lines when we're plotting a point. So just identify it. The point is here, and you circle it. The next point, I'm not so sure. Let me go back. All right, -4, 5. Sorry, so -4, 5, -3, 0. Okay. -4, 5, which is here. -3, 0, which is here. -2, -3, which is here. -1, -1, -4, which is here. 0, -3, which is here. 1, 0, which is here. 2, 5, which is here. And 3, 12, which is here. So we plot all our points, and the only thing left now for us to do is to draw our graph. All right, now the parabola is a curve. Remember, the parabola is described as a smooth curve. So whenever you're drawing a curve, you're drawing a graph, which is a curve, it must be done via using freehand. All right, so this is gonna take some effort. I'm just gonna prevent the screen from rotating. I don't know why this thing hit me now. All right, so I'm gonna draw my graph. Now, whenever you're drawing your graph, what you need to do is you need to position the graph sheet and so that the graph is comfortable for you. So it's comfortable in terms of where for your hand position and for the movements that you need to do. Position your graph so that it's comfortable in terms of when you're drawing it. So I would turn mine. You're not seeing the turn because I just prevented the screen from rotating. Then I'm gonna put the point of the pencil at the point where I want to start from. Then with each movement of my hand, I want to go through as many points as possible. When you're drawing the graph, do not follow the pencil point with your eye. You simply look at where you want the pencil point to go. So let us, by trial and error, draw a graph. All right, not bad, but certainly not perfect. So I'm doing it over. All right, so I just draw 1/2 of my graph. So I need to draw now the second half. All right, now, if I make it look easy, please do not think it is easy. It isn't. It's something that requires practice. So this is the graph of y is equal to what? X squared plus 2x minus 3. It's y is equal to x squared plus 2x minus 3. The number at the end being the y-intercept. So this graph cuts the y-axis at -3. What else? After you finish drawing your graph, you must label your graph. The next thing we need to do now is we need to use now our graph to answer questions. Let's see if we have any question around here. No, we don't. So this is our graph, and this is our first question. Use the graph to determine the minimum value of y. Now, the minimum value of y is the value of y at the lowest point on your graph. So at the lowest point on the graph, I'm going to draw a horizontal line. Using my ruler, this thing must not be done using freehand. It must be done using my ruler. And this is the line y is equal to -4. So you will get the minimum value of y at the lowest point of the graph. The lowest point of the graph is at the point where y is -4. And x at the lowest point of the graph, that's the vertical line through the turning point. The vertical line through the turning point is x is equal to -1. All right. So the value of y at the lowest point of the graph is y is equal to -4. And the value of x at the lowest point of the graph is x is equal to -1. The vertical line through the turning point is x is equal to -1. Let's answer the questions. So the first one, use the graph to determine the minimum value of y. I would answer y min is equal to -4. The minimum value of y for my quadratic function is y is equal to -4. Next, we're asked for the value of x for which y is a minimum. So the value of x for which y is a minimum is the value of x at the turning point. We already identified that x is equal to -1 is the value of x at the turning point. So x is equal to -1 is the value of x for which y is a minimum. Guys, next we need to know the coordinates of the minimum turning point. Well, we know that the value of y at the bottom is -4. We know that the vertical line through the turning point is, so the horizontal line, the vertical line through the turning point is x is equal to -4. The horizontal line through the turning point is the vertical line through the turning point is x is equal to -1. And the horizontal line through the turning point is y is equal to -4. So guys, -1x -4y is the minimum turning point. The coordinates of the y-intercept, guys, remember the y-axis the graph cuts the y-axis at -3. The y-axis is the line x is equal to 0. So x being 0, y being -3 is the y-intercept. Remember, we already identify that the vertical line through the turning point is x is equal to -y. And guys, the vertical line through the turning point is called the line of symmetry. So x is equal to -1 is the line of symmetry. All right, so next we're gonna have to go back to the graph now to answer these questions. All right, we're gonna have to go to the graph to answer these questions. Let's put in some color. Let's put in green. So the first thing we want to know is the value of y when x is equal to -2.5 and the value of y when x is equal to +2.5. Back to the graph. Guys, when the examiner is asking you for the value of y when x is equal to -5, what he's asking you to do is to identify the point on the graph where x is equal to -5, and at that point, determine the value of y. Guys, remember, every point on your graph has a value of x and a value of y. The examiner is saying to you, identify the point on the graph where x is -5, and at that, when x is -2.5, and at that point, determine the value of y. This is where x is -3, where x is -2, -2.5 is in the middle between -2 and -3. So this is the vertical line. X is equal to -2.5. And this is the point on the graph where x is equal to -2.5. Guys, the first thing we need to do is to identify the point on the graph where x is equal to -2.5. How do we do that? We, at x is equal to minus 2.5, we draw a vertical line until it touches the graph. Wherever that vertical line touches the graph, that is the point on the graph where x is equal to minus 2.5. At that point, we're going to draw a horizontal line. Now, this horizontal line is the line y is equal to minus 1.8. Remember, these minor divisions is actually 0.2. All right. I'm a little perfectionist, you know. All right, good. I'm gonna bring this over. Being the little perfectionist I am. All right. Remember, each of these minor division on the y-axis is 0.2. So if this is minus 1, 1.246, this is 1.8. So that horizontal line is the line y is equal to minus 1.8. So at the point on the graph where x is equal to minus 2.5, y is equal to minus 1.8. The next thing we're asked to do, guys, is to determine the value of y when x is equal to 2.5. All right. All right. So the first thing I need to do is to identify the point on the graph where x is 2.5. The perfectionist in me wants to fix something. I want to fix in between here. This line should have been a little bit straighter. A little better, but still not perfect. All right, that's better. All right. So let's identify the point on the graph where x is positive 2.5. Guys, everybody pay attention. This is x is equal to 2. This is x is equal to 3. 2.5 is in the dead middle between 2 and 3. At x is equal to 2.5, I'm going to draw a vertical line until it touches the graph. Whenever it touches the graph, I'm going to draw a horizontal line. Guys, this horizontal line looks like it is the line y is equal to 8. So when x is equal to positive 2.5, y is equal to 8. When x is equal to minus 2.5, y is equal to minus 1.8. So to answer my questions now, I'm going to tell the examiner when x is equal to minus 2.5, y is equal to minus 1.8. Also, when x is equal to positive 2.5, y is equal to positive 8. H is asking for the value of x, the values of x when y is equal to 2. And I is asking for the roots. H is asking for the values of x when y is equal to 2. Go back to the graph. So what I have to do is I'm going to identify the points on the graph where y is equal to 2. Let's use a different color ink. I think I'm probably gonna have to go back to black because let's go back to black. Let's identify the points on the graph where y is 2. I'm gonna draw the line y is equal to 2. That's that line there. Label it, y is equal to 2. It meets the graph here and here. Those are the 2 points on the graph where y is equal to 2. Let's get the values of x. Where y is equal to 2. This is a value of x here. All right. And over to the right. This is a value of x here. Guys, this is what it looks like to me. This looks like -3 minus 3.45. It don't reach -3.5 yet. It's between -3.4 and -3.5. So it's -3.45. Over to the right. All right, I think if I'm being honest, I should carry this over some more. All right, so now let's leave it there. So this looks like x is equal to 1.4. This is here is x is equal to 1.4. So at the point on the graph where y is equal to 2, x is equal to -3.5 and x is equal to 1.4. The roots are the values of x where the graph meets the x-axis, which is -3 and +1. Those are the roots. So to answer these 2 questions, the value, so x is equal to -3.45, and x is equal to 1.4 are the values of x when y is equal to 2. Remember, the roots are the x-intercepts. The roots are the x-intercept. So the x-intercepts is -3 and +1. So x is equal to -3 and x is equal to 1 are the roots of y is equal to x squared plus 2x minus 3. Guys, I know the question is a mouthful. You just have to review it, rewatch the video if necessary. And there's one last thing we have to answer. And then we can stop this video and review the question if necessary. The one last thing we need to answer is this. This is asking for the interval within which x lies when y is less than minus 3. The interval within which x lies when y is less than minus 3. To answer that, we have to go back to our graph. All right, so the first thing we need to do is we need to draw the line y is equal to minus 3. Let me see if I can find a different color to do this so as to, I don't know. The only other color I can think of is green. It's the only one I could think of. Or increase this and use blue. All right, let's use blue. What we want is the interval within which x lies when y is less than minus 3. To answer that, what we need to do is we need to draw the line y is equal to minus 3. This is the line y is equal to minus 3. So this is the line y is equal to minus 3. All right, so it cuts the graph where it meets the graph where x is equal to minus 2 and where x is equal to 0. So this is x is equal to minus 2 and this is x is equal to 0. This is the y-axis, which is the line x is equal to 0. So guys, my graph exists within three regions. Yeah, within three, yeah, four. This is what actually literally 6 regions. Is it 6? Yeah. 3 above, 3 at the bottom. Tell me if you agree with me. Above this line, y is greater than minus 3. Well, you don't have to tell me. Above that line, y is greater than minus 3. Below this line, y is less than minus 3. We are interested in the region where y is less than minus 3. To the right of this line, x is greater than 0. To the left of this line, x is less than 0. To the right of this line, x is greater than minus 2. To the left of this line, x is less than minus 2. All right, let's put in some different colors now. So this is one region of my graph. This is one piece of my graph. That's blue. That's one piece of my graph. Let's make this another piece of my graph. So the blue part of the graph is where y is the part of the graph that is above the line y is equal to minus 3. Now, this is the region of the graph where y is greater than minus 3. What I'm interested in is the region of the graph where y is less than minus 3. Change into green. This is the region of the graph. This is the region of the graph where y is what? Less than minus 3. That's the region of the graph where y is less than minus 3. So the green region of the graph is where y is less than minus 3. And the blue region of the graph is where y is greater than minus 3. What now? if you look carefully, you can see that here, if you look at so this is where x is greater than 0. X is greater than 0. All right, let me move from there. This is where x is what? Greater than 0. Where x is what? Less than 0. Where x is greater than -2. Where x is what? X is less than, where x is less than -2. So the green region of the graph, guys, the blue region of the graph is where x is, for this region of the graph, that's where x is what? Greater than 0 and y is greater than -3. This region of the graph is where x is what? Less than what? -2 and y is greater than -3. I am interested in the region of the graph where y is less than what? -3. This is the region of the graph, guys, where y is less than -3. And in that region of the graph, x is less than 0 and x is greater than -2. So to answer the question, to answer this question, I'm going to say that x is less than 0 and x is greater than -2 is the region on the graph, are the values of x within which y is less than -3. Within those values of x from -2 to +0, the graph is below the line y is equal to -3. And that's the end of the question.